Okay, so this slide is very important, and here I'm going to provide you the different features that you will be able to read from a laser scanner when you use ROS or ROS2. Okay, so basically a laser is something similar to this one. Is going to send a beam of laser with respect to a certain field of view, and here we have the information about the field of view is the minimum angle and the maximum angle. Okay, so here we have minimum angle, which is negative, and positive angle, and then this will correspond to a certain field of view. So what is the field of view here? It's 120 degrees or 124 degrees between the minimum angle and the maximum angle. The angle increment, so you have a continuous range, but we cannot read continuous, it must be discrete. So you will have, for example, 180 degrees, but you will be able to read 1 degree from one increment to another. Imagine that you have 120 degrees, okay, and you can read an increment of 1 degree. So how many values you are going to collect? You will collect 120. If you have, for example, an angle of 0.5 degrees, you will be able to collect 240, and so on. Yeah. And so the angle increment, it's called the angular resolution. طبعا when the angle increment is smaller, you will be able to detect more obstacles. Okay, imagine that the angle increment is 60 degrees. How many obstacles you will detect? 3: minimum, middle, and maximum. Sorry, if you have 120 degrees and the increment is 60, you'll have 3 points: the left one, the middle one, and the right one. Now if you have maximum 3, yeah, because usually the border is not always. You will see, for example, this is claimed to be 270, and you will find it at 255. Okay, so for example, if you have 30, you will have maybe 5 readings or 4 readings, something like this. So when the angular resolution is higher, it means it's minimum lower angle increment, you will have more values that you can read from the laser. So the time increment is the time between two measurements. Okay, because the laser is going to give you, for example, at a certain frequency, maybe it will give you 10 measurements a second or 100 measurements a second. In some of the lasers, you can configure the values.
Does it depend on the angle?
No. These are two things. In the ROS topic, when you subscribe, how many messages per second? This depends on, yeah. So same thing, it's the number of messages per second that you'll be able to read from the laser. And this is expressed as the frequency, 100 hertz or 50 hertz or 20 hertz or 10 hertz. Okay, of course, the higher the hertz, the higher the frequency, it will be better, because especially in control algorithms, you need to have high frequency in order to be able to process at every microseconds or very small amount of time between any two readings. So the scan time, it's the time between the two scans. And the maximum range, it's the minimum and the maximum range. This is the range that is observable by the laser. So in principle, you will find this is specification, but in reality, it can be a little bit higher or a little bit smaller, depending on the quality of the sensor, and probably some other things can affect, like for example, interferences or the nature of the obstacles. Many things can actually affect the performance of the scanner. And then the important parameter here is the list of ranges. This is what we are going to use in ROS2, list of all measurements in a scan. So this is what will return all the ranges around. And this is what we will be able to process, for example, in Python or in C++, in order to make some reasoning about where the obstacles are located and what action I have to take into account. Okay, for example, I can make a robot move, and then if the minimum obstacle distance to obstacle is, for example, less than 0.5 meters, I want the robot to stop. Or maybe I will ask the robot to move left or to move right, depending on where the minimum, the closest obstacle is. So we will discover this, and there is also the list of intensities, this depending on the intensity of the light that comes into the laser. So the range is basically in Python or in C++ a list of values, okay, that will return different distances from different angles. It will start from the left, okay, give you a distance, then a distance here, then a distance here, then a distance here, until it comes to, so you will have all the distances depending on the angular resolution and the maximum range and the minimum range. Okay, so the list of ranges, they can be used in different ways. First of all, in 2D laser scanner to detect obstacles and avoid them, and also to make localization and mapping. So this is something that we are going to explore further with the navigation. Okay, when we detect obstacles, there are some algorithms that are called SLAM that allows you to build a map. Look, for example, here, this map is something that you can build with a robot using a laser scanner. And you will see we will have here a free space, and here we will have obstacles. So these obstacles are detected by the laser, and then they will be fused by the SLAM algorithm. So this laser reading will be fused with other readings, like for example, odometry or other type of sensors, in order to decide which place in the environment is free and which space in the environment corresponds to an obstacle. Okay, so this is something that we will be able to do by exploiting or leveraging the list of ranges that we have here in the measurement that we collect from the laser scanner. Navigation also, after we build the map, we can navigate in the map autonomously, and the navigation will have what we call a global planner to plan a path. Okay, and when you want to plan a path, you will, so the planner will plan it in the free space in the map. And the local planner, it will be responsible of executing the global path and avoiding obstacles while it moves. So the obstacles can be dynamic. I mean, for example, you can have an empty space, but there is a person crossing through the obstacle or crossing through the robot. So in this case, the robot needs to take decision based on the laser information that will be received from the scanner. Object tracking also, it can be used for object tracking. So there are different types of commercially available laser scanners, like for example, this one is the Hukoyo URG4LX, and it is characterized by a maximum range between 1 meter and 5 meters, or 0.1 meter, a centimeter, this one, and 5 meters range, a maximum field of view of 240 between minus 120 and 120 degrees. It's designed for indoor environments, and it has a scan frequency of 10 hertz. Okay, this means that how many scan value per second do you return? No, 10 hertz, it means 10 messages per second. Okay, so this means it's 0.1 second, 100 millisecond per scan, 0.1 second per scan. It means 10 messages in 1 second. Okay, and it operates with a voltage of 5 volt. So this one, you can plug it into a laptop or a computer with 5 volt. It will be able to operate. Some other lasers, they will need higher voltage, like for example 12 volt, 24 volt, depending on the power they will need. Okay, when we increase the range, we need more power. So 5 volt for some of the lasers is not sufficient to get large distance. Operates on USB 2.0, and the price is a little bit higher than $1,000. So we have also RP LiDAR A2, which can give, this is the lower cost, and it has also a comparable quality. It's yeah, this is Japanese, the other one is Chinese, so the brand also can play a role. But in terms of efficiency, this is very efficient. We have been using this for the quality of navigation and SLAM. The RP LiDAR give us a better performance because it has a maximum field of view of 360 degrees. So we have a complete view of the environment. This one gives only a partial 240. And it has also 6 meters, so they are comparable here. used for indoor, 10 hertz, 5 volts, and consumes. So very comparable. This one is used on UART, but of course we can have UART is particular type of serial ports, but we can actually have adapter to make it on USB as well. Okay, and this actually counts. You know, this needs only USB 2.0 because it's only at 10 hertz. Maybe if you have a very high frequency, in some cases maybe we need higher USBs like a USB 3.0 and similar. Now, these are some bigger laser scanners. And look, this one is at 12 volt, and this one operates 10 to 30 volts. Okay, because they give 20 meters, 30 meters, and they are planned for outdoor. So usually outdoor we need bigger ranges because the space is more open than within an indoor environment. An indoor environment usually have obstacles every 3 to 4 meters, 5 meters you can detect an obstacle, but in an open space, maybe you can have obstacles at some tens of meters away. And this one has different type of interface. It can be connected on serial, like USB, on Ethernet, or also a CAN bus. This is an industrial protocol that is used in most of the vehicles that we drive today. Okay, and it's kind of a collision avoidance protocol. And the price is very expensive. It's more than 5,000 USD, and operates at a frequency of 25 hertz to 50 hertz. This one is at 40 hertz operational frequency. So we can also find laser scanner in what we call depth cameras. So these are cameras, stereo cameras, like for example the D415 RealSense from Intel, and also the R200. So they work basically as RGB camera, but they provide also an additional sensor that gives us the depth. Okay, so this is equivalent. I can see it's. I cannot say it's equivalent to a 3D LiDAR. They don't have the same thing, but it allows to make 3D maps. Okay, because of the depth sensor. So when you have an image, which is 2D, the laser scanner inside or the depth sensor inside can also give you how far a pixel in the image is. Okay, in this case, this is what we call the depth image. It's an image 2D, but also it gives you another dimension in the Z direction, which is the depth. And usually they give around 5 meters. They don't have very large range. Okay, and this one is 3.5 meters. Field of view is also most of the time limited. It has horizontal and vertical. So like the 3D LiDAR, I mean, it's over the 2-dimension, horizontal and vertical. And it's used on indoor. This is not appropriate for outdoor. And they have also certain resolution. This is full HD at 30 FPS and operates on 5 volts. And here it uses USB 3.0 because images, they consume more bandwidth than pure laser beam. And the price is affordable. It's 150 to 250 US dollars. We have also some other type of laser scanner, which is called the LiDAR Lite version 3, which only gives one beam in one direction. It doesn't have any, it only have one beam, just in the front direction. And this one can give up to 40 meters, but only one beam in the middle. There is no left and right, okay? There is no field of view. The field of view is 0. Only one direction, the front direction, and it consumes like 5 volt. It can be used in indoor and outdoor environments, and has an optical aperture of 12.5 millimeters. It can work on I2C or PWM interfaces, and the price is 130 or around 130 US dollars. And one of the usage of this laser scanner is in on drones. Okay, for to have a better altitude estimation of the drone, especially when it is landing and also taking off. So for example, in some of the drones that we have here in the lab, we put this looking down to the ground so that we can have a good estimation when the drone is landing to the ground, what is the distance to the ground, so that we control the speed until the drone is completely landed, and also in the takeoff. Okay, there are other sensors, like for example barometers or ultrasonic, but usually they are not very accurate and they are very sensitive to the noise. Usually this kind of laser, they provide much better accuracy in terms of the distance estimation. Okay, we can use also them into the robot to detect like far obstacles in the front direction. That could also be used. But I mean, it's not really common to use them in robot, right? It's mostly on VOVs. I've seen this mostly on VOVs.
Aerial vehicles.
Aerial vehicles, yes.
Maybe
Fire guns also.
Hmm?
Fire guns or something. Use it.
I don't know whether this is used there.
but,
Yeah.
maybe they are using it in underwater.
So yeah, I've mostly seen them on the UAVs and some gimbal cameras. They augment 1D LiDAR to the gimbal
Yeah.
next to the camera to give a sense of estimation where the object that's seen by the camera is, how far it is.
Yeah. Okay, so now basically when you work with ROS2, you can work with any laser scanner almost in agnostic manner. The most important thing is that you need to have a driver, like any other device. If you have a camera, if you have motors, if you have a laser, if you have any sensor or actuator, if you have a ROS driver, so later on, from coding perspective, okay, the code is completely agnostic to what kind of hardware are you using. So for URG, you can download this from Debian. Okay, so this is now the documentation page of URG on ROS2. It's accessible, and you can install it using sudo apt install ROS. I'm using Humble. If you're using another version, so just change this by your version -URG. Okay, so this is the company name --. It will install all related packages.
Oh, so they have drivers for ROS2? Humble?
Yes. Now URG is supported by since the early versions of ROS. Okay, so in order to work with this laser or any other laser, first of all, this is the process. Start the drivers. Okay, make sure that the scan topic is available. So most of the lasers, they are going to publish on the scan topic, and we can write a node that subscribe to the scan topic. And finally, we have a callback to process these messages. So this is what I'm going to show in a moment. So this is the way on how you can start this laser scanner. We use ROS2 run URG node driver, and then we give the path to the parameter file. I'm going to show you this parameter file and what kind of information you find. So this is the general instruction, and here the specific instruction. I have to put ROS2. Okay, ROS2 run URG node, and then we specify the parameter file. It's this path. Okay, when you install the driver, you're going to have a launch file that will contain the configuration of the laser scanner. So by default, it's going to connect on the USB port on a certain port that is called TTY ACM0. It can change, and we can change it also in the configuration file, as I'm going to demonstrate in a few moments. And okay, this is optional, but this is if you want to visualize on RVs. So usually RVs, it expect to have a map frame. So in future lectures, we will discuss in details about frames and why we need frames. But in summary, a frame, as probably I have explained before, it will tell you in which context you are going to express a certain coordinate. So usually the map frame is what we call the global coordinate frame. It's like the word frame. Okay, for example, we can say this laser is located at coordinate 4 meters in this room map. Okay, but this laser, it's located at 0, 0 with respect to its current frame, which is attached to this scanner. Okay, so this is it's going to make a map between what is the coordinate of the laser with respect to the map. That's pretty much it for the moment. And this is also some other information about RP LiDAR A3 if you want to play with it. It has another driver. Okay, I put information for different type of LiDARs. And the process is basically the same. So let me go now to the virtual machine. So first of all, I'm going to start this laser scanner. So I have the hardware with me right now, and I'm going to connect it to the machine. Okay, let's take this command and paste it here. So before pasting this command, okay, let's look what's inside here. First of all, you need to do sudo apt install ROS humble.
For installing, should we update?
No, it's fine. Why it's not auto-completing?
You update and
Okay, let me write all of this. Okay, it's already installed. So this is the first thing that we need to do, installing the driver. When you install the driver, so it will be located somewhere in the /opt/ROS and our distribution. And here, inside share, okay, I'm going to look for URG. We will find it, URG node. And here we have a launch file. So there are different launch files if you are going to connect through Ethernet, but basically we are going to connect through a serial port, which is a USB. So let me open this file here, and you can see the configuration. So it specifies the maximum angle between 360 degrees, okay, minus 80 to 80. I think this is probably not correct for this configuration. I can change it. So it's minus 20 to plus 20. So let me change 120. What is the equivalent in pi? Divided by 1/3, 80, multiplied by 3, 14. It's 2.09. Okay, 2.09 here, and here it's 2.09. Of course, this configuration corresponds to the laser I have in hand. So maybe this was a configuration for other laser that have 360 degrees from Hukoyo, but I have this one for now. Okay, so the port we should not change. This is the serial port. I'm going to show you this serial port later on. This is the baud rate. It's the how many bit per second will be exchanged through the serial port. This is the default laser frame, which is laser. It's usually laser in ROS, unless it was changed. The calibrated time. Okay, so these are the most important factors. So I cannot look if I want to save here, is not going to allow me to save. Why? Because this is I don't